Hey guys, we're Everything Astronomy. I'm Sam.
I'm Michael.
And I'm Joe. I'm Tommy.
And we're a group of 4 university students studying physics and astronomy. We hope to share our passions not only for space exploration, but for science in general.
Let us know if you have any feedback or if you would like to see any topics that you want us to discuss next. We hope you enjoy our podcast.
Hello, welcome to our first podcast on Everything Astronomy. My name is Michael.
And my name is Joe.
And we're both students here at the University of Michigan studying physics and astronomy. Today, we're joined by Professor Liemohn, who is in the Department of Climate and Space Sciences and Engineering, with whose help we hope to share our love and interest in space exploration.
Professor Liemohn received his PhD here at the University of Michigan in 1997 and has been involved in research and teaching since. His research involves quantifying the motion of charged particles in the space environment around Earth and other planets. On top of his research, he's been involved in a number of committees at NASA and is the director of the newly created Space Institute at Michigan.
Cool. Thanks for joining us today, Professor Liemohn. How are you?
Thank you for having me. Yes, I'm doing well.
Awesome. So we have a bunch of space-related questions, and we figured we'd start it off with maybe an interesting question about being a professor and like what the day in the life looks like for you.
The day in my life, a lot of meetings. I seem to be shifted away from where I started my career in more of a researcher mode, where I was writing a lot of the programs and doing a lot of the analysis, and now I feel like I'm more in a manager mode in helping grad students and others do it. And so, yeah, my days now, what it looks like is that I'm going from one committee meeting to class to another type of interaction with others. It's a lot of talking. It's a lot of different than what I thought it was going to be long ago, of just sitting in your lab, typing away, doing your thing, or working on your project, and occasionally shouting "Eureka!" and then going back to
So that's definitely been like a transition from graduate school and being a postdoc, like a researcher for the department, and then now finally being in a professor position.
Yeah. I think that's a natural transition. I think that you go through over the course of your career, and that it's a process where you want to help others join the field too. And I think that's been my natural progression, is to want to share what I know, what I've learned, and how I've and not just the stuff about astronomy and space science that I've learned, but the process of how you do that.
Definitely.
And so that's the
kind of giving back and being a mentor as you were once mentored by
yes,
people.
exactly.
Awesome. Cool.
And so how, obviously the interest as a child gets sparked by sort of the fantastic of space, but that clearly has to evolve through high school, undergrad, grad school, postdoc, professorship, and even then I'm sure that the reasons why you stay interested in the field keep on evolving. So what first you got interested in the field as a young boy, and then how did that evolve, and how did that keep going?
Yeah. So I tried to think about when I first wanted to be a scientist, and when that was exciting to me. I think it was reading a lot of books at home and looking at things. My dad had a telescope, and we would go out in the backyard sometimes and look at the moon, and I'd see it. And, okay, yeah, that's nice. I actually liked much more reading a book about the moon and seeing, because the pictures in there were better than what I saw through the telescope, and far more informative with all the extra words around it. So I guess I was a book lover starting from an early age in terms of how I like to learn. Somewhere like in 6th grade or something, one of my teachers asked everybody, "What do you want to be when you grow up?" And was writing everything on the board, and I remember answering scientist at that time. So even back that early, and then he scared me, because he then listed what it would take in terms of schooling and like startup costs to be that type of a position. And so, you want to be a scientist? Oh yeah, you're looking at a decade of school past high school, and you're looking at $1 million to start up your lab or something. You had to do it from scratch, or even more, to buy all this equipment.
Yeah. But even like growing up during like the Apollo era and going to the moon, like they didn't like want to advertise being a scientist in that time period, or was it more like frowned upon?
So when I grew up, I was born in '70, so I was kind of before. The Apollo era was before me, but I grew up in the Space Shuttle time period.
Okay.
So yeah, when I was in that formative years of late elementary through high school, trying to pick a career path and where you want to go. That was the time when space shuttles were doing their first flights, and distinctly remember that first flight of the test flight of Enterprise, just sort of going up off the back of a 747 and landing. And, ooh, yeah, this is that's a neat
And
thing.
speaking of the space shuttle, what did you think of it as it was coming out, and then more as your career progressed? Because you had all the excitement in the late 50s, early 60s to late 60s of, oh, we sent a man to the moon. Oh, we sent a dog to space, and then 10 years later, there's a man standing on the moon, and then
Eventually, you're just going to not the moon, 250,000 miles away. Now all of a sudden, you're going to low Earth orbit, and you're staying there.
And
Yeah,
then
right.
the space shuttle has a fairly boring routine thing. How do you think that how did the sort of the interest, the popular interest in space shift, or did you see it change over time as we started realizing that space was a very costly endeavor, and that perhaps sending a man to the moon doesn't have that much economic benefit apart from just saying that we can do it? So how's that changed? How has that affected your interest, your career?
Well, I think so I guess a couple things. One is, I think that the space station, space shuttle does serve a very important purpose, and that is permanent life in space. That we now have humans that have been in space, with the shuttle flights regularly throughout the 80s and 90s, and then the creation of the space station in the first flying in the early 2000s, and being a permanently inhabited thing. Not only us, but other countries too. If you go back to Mir, we've had a human presence in outer space for decades now, and so I think that's important to establish, and I think it's good to acknowledge that and celebrate that as a big accomplishment. So yes, we've only been going to low Earth orbit, and that's kind of sad and disappointing that we haven't been off to Mars by now. That would be great if we had kept doing that, but you're right, it's expensive.
Yeah.
Really expensive.
I mean,
to do the big launches.
The ISS is the most costly.
It's like $3 billion to fund every year.
Every year.
Every year, yeah.
It's
on that
$150 billion endeavor, and I think this is an interesting point to raise of how does science get funded? I personally think it's very important, and I'm sure you do too, but could you explain why you think it's important to keep funding research, to keep pushing the limits of human knowledge, to keep spending money in fields that maybe don't seem to have so much practical repercussions on people's lives?
I think that they spur our imagination, and so they keep us engaged with the learning process and motivating us to want to be better people and want to know more about how things work. And I think it's important for us to keep that spark going. And I think that sciences in general, not just astronomy and space science, but any field where we're doing research is into whatever that topic may be. If we're learning something new, I think that's an important aspect of humanity in general, just for us to feel like we're
it's kind of it's a very innate quality to be curious and ask
yes,
questions and look up.
But it's satisfying that curiosity need in a positive and fruitful way. So
And I think something a lot of people may be thinking sitting at home or listening to this is, we're spending billions of dollars in space, and even though it's sparking our creativity, where are they seeing something tangible coming out of it? A space probe sent thousands of miles out in the solar system. Are they reaping the benefits from that in some way in our culture or society?
It's often hard to see that. And so, yes, I agree that there is the trade-off of what are we spending our money on. Yeah. And I think that puts a big burden on me. I feel like I'm very privileged to be in the job that I have, and I'm very thankful for it and grateful for the United States, for the world to want to fund scientific research in general. So I try not to abuse that power and want to spend it wisely and correctly so that we maximize the return from that. Why should we keep spending for it, and what is the eventual benefit? Well, there have been direct benefits. So just the expansion of what we can do as a society based on space travel. So and it affects our lives right now. So we have Sirius XM, we have DishNet TV, we have anybody that consumes weather information in the United States gets that information from the GOES satellites. So the National Oceanic and Atmospheric Administration has put up several satellite systems, and one of them is GOES, which is the Geosynchronous Orbiting Environmental Satellites.
Oh, yeah.
Those are the ones that take the picture of the cloud cover over the United States. All the other companies that then give you weather reports get it from NOAA, because they're the only ones with those satellites up there giving those pictures. And so we need to have that space view in order to really understand the weather system. So it directly impacts our lives every day.
I think that's a very interesting point, and especially the one with the culture of researching, of sparking curiosity, of keeping the dream alive. And as I look back in how society and humans have evolved over the last couple thousand years, there was a whole point from probably the year 500 to the year 1500 where, at least in Western Europe, we didn't really develop science that much. And then all of a sudden, at the time that Newton is around, Leibniz and Huygens and all of his contemporaries, the culture sort of shifted to this more, let's follow the scientific method, let's follow more rigorous thought, let's start doing. I suppose there was a culture sort of created itself that lended itself better to science and discoveries. And you're now involved at NASA quite a bit. And so how do you view that your role at NASA in sort of shaping the future outlook, or how does your role at NASA help keep the curiosity alive and make sure that humans are always, or that at least the direction that we're looking at is a fruitful one?
Yeah, I think that's I am on a NASA advisory committee right now within their committee structure that they try and get input from the outside on making sure that NASA is spending their money wisely and fruitfully. So I try and give input there that helps them steer it in that direction. So how do we do that? We think about what could be not just, so there's a big trade-off here, I guess is what it comes down to, between doing what is safe and a good investment of money in the sense that we know it's going to work, but that often leads to simply an incremental increase in our science, or doing something that's bold but perhaps risky. And so you want NASA to have a nice balance between doing things that we know we can do and keep advancing the forefront of knowledge, as well as do something large and go for a big advancement where it may not actually work. So so you want them to do both.
And I guess you can see that now with the government wanting to go to the moon again, where we have this large idea, this large project.
Yes, right.
Then beneath that, we also have these smaller projects sending out small probes, or developing smaller telescopes around the Earth.
Yeah, so having that balance between the robotic missions and the human spaceflight missions into deep space. And I think that NASA tries to do a really good job of balancing those two, and I feel fortunate that I get to be part of that conversation and part of the advice to them on that.
And then that's like an interesting thing you just raised is they're like sending out robots versus sending out humans.
Yeah, right.
And so sending out humans beyond low Earth orbit, beyond the International Space Station. Do you think there's a benefit to spending that much money on sending a human to Mars, a human to Earth, or not to Earth, to the moon, compared to sending out hundreds of robots for the same price, or hundreds of rovers?
That's a tricky question to answer. I think that's one that will get people going on both sides of that comment of no, we shouldn't spend any money on humans because we really aren't doing a lot with the humans once they get there. But I think it's worth it to spend money on human spaceflight because I think it captures the imagination. Again, the whole Apollo program you brought up, and seeing the space shuttles go up for the first time, those are exciting. And you get the entire world pumped up about what humans can do. And so, yes, it's a lot of money, and there has to be a lot of safeguards to ensure that the money is spent wisely and correctly, and try not to fail. And so a lot of extra reviews and checks in the system so that you have a successful mission at the end. And but I think it's worth it to send people there. You do have to do a balance and make sure that you aren't overspending on that side of things. So that's where you need to look at budgets carefully and see, don't do this at the expense of the other one completely, or vice versa. I think we need both.
I mean, personally, one of the things that got me very psyched about science, physics, astronomy, and came from space, and the idea that you see in movies, in books, in comic strips about sort of deep space exploration, sending out humans to the far reaches of the universe. But my current understanding of the laws of physics, and I think the prevailing opinion on the laws of physics, tell us that humans can never really go that far. We can't really spread to become a multi-star, multi-galaxy species, and that Earth is kind of it. Do you think that at one point humans will sort of revisit the idea that we should try sending humans back even outside of the solar system, or is that on a hiatus for the foreseeable future?
I think the latter, hiatus for the foreseeable future. I think that we can go as far as the moon and Mars, space stations, for the foreseeable future. I think that's as far as we can and should go. Again, it's this balance of what we can really afford to do. And sending people all the way to another star, it would be, first of all, a one-way trip for those for that crew.
But kind of left to science fiction for now.
Yeah,
and eventually maybe it'll become science.
Yeah, eventually. So I have a lot of hope for humanity that we will overcome those obstacles between here and there to make interstellar spaceflight a reality. But within my lifetime, no. Within your lifetime, probably no. Within, it could be centuries away before we've actually gone to the stage of being able to have the engines and the life support systems and the other systems in place to protect those people on that long journey. Space is actually pretty hazardous for people. We're pretty soft when it comes to the dangers that exist in outer space.
And speaking of going to Mars and to the moon, and just having a human presence in outer space, has that given you and given the dangers that we face from climate change, does that change your perspective? Does someone who understands how the Earth is in some sense our only vessel, how does that tie into climate change? Do you think that it's worth trying to look at Mars and hypothetically terraforming Mars, or how do you think that humans should best tackle climate change? This is a very broad topic, but I think there's a lot in it.
It's definitely an intersection between space sciences and trying to do the best for the planet Earth.
Oh, I think in the foreseeable future there is no planet B. We have to help planet Earth right now. Yes, we will be sending humans to the moon and Mars within the next 50 years. We'll probably have a colony on Mars. I think it'll be a few humans. It's not going to be civilization as we have it here. So we need to protect this planet, and I think that we need to be investing, again, that balance that we were talking about. I think we need to be investing heavily in climate change research and mitigation strategies immediately. I think that it's an important topic. It's definitely coming. It's already here. We're already seeing the influences of changing climate and the adverse effects that are going to happen to large swaths of our population that are coastal and in developing countries that may not have the resources to handle those changes. There's going to be socio-political issues with climate change that the world has to deal with very soon. So we need to be investing money, and if we can engineer a solution or mitigation strategies around it, we need to be doing that very soon.
As the director of the Space Institute here, which is newly formed, and just a professor who's in climate sciences, do you see the scientific field turning its focus more towards climate change? Has that already happened? Are there more professors and scientists, researchers who are turning to trying to solve climate change, or is that something that's still largely in the field of activism and it hasn't yet reached the academic circles?
Definitely in the academic circle. Yeah, our department changed its name a few years ago specifically to put climate in the title because so much of our atmospheric sciences half of the department was not doing straight up atmospheric science, but more climate system science and looking at the land-air interaction, ocean-air interaction, longer term scales than just meteorology in immediate weather, what's going to happen tomorrow type questions. Yes, it's already here. We have a very strong and robust climate physics group in my department, and it's definitely something that students can and should be thinking about.
And then also with your research on campus, so you're taking advantage a lot probably of those satellites you were talking about before,
Yeah.
orbiting Earth. But it seems like instead of looking down at those satellites for you and your research, you're looking up instead, or kind of like collecting data from the atmospheres of planets or Earth. Did you want to maybe kind of, because we tried trying to understand your research and trying to read through those long terms.
Oh,
and,
yeah.
So what is it exactly, like briefly, like that you do here on campus
That I
as
do?
a researcher?
Yeah, as a researcher. So I do sort of several things. One is write numerical models. So this is taking the equations of motion for how we think charged particles move through planetary space environments. Those big words that we were using earlier. Yeah. So those are electrically charged particles. These are little electrons and their counterpart, the ion. And they're moving through deep space, and we think of the vacuum of outer space, and we think that that's empty, but empty only to a point. It's definitely empty compared to the air we're breathing now. It's not enough. It's not thick enough for us to live out there like we are here. But it does have some number of particles, and those particles, because it's been evacuated down to such a high degree, there's lots of room for those particles to get going really fast. So what I like to do is to look at the equations of how those particles should be moving, and we have a pretty good handle on what some of those equations are, and then come up with apply numerical algorithms to come up with computer programs that solve those equations. And there are lots of ways to do that. So I have my ways that I do that, and there are many other people in my department that are in numerical modeling and numerical algorithm development for solving these equation sets. Then we also I also spend half my time looking at the observations from these scientific satellites. So satellites that are out in deep space with sensors on them, with cameras on them, taking measurements either locally or remotely of the space environment, of this very tenuous charged particle environment and the electric and magnetic fields that are associated with them. Okay. And I try and come up with the connection between those. And yeah, we have a good set of the equations, but I think where my research is right now is at the nonlinear interactions between those different regions, between those different charged particle populations, between the charged particles and the electric and magnetic fields. And there's a big interplay of energy between those different regions, systems, populations, and that's where I like to invest my time and try and advance humanity's knowledge.
In high school, they told us that the reason why Earth is so special is because we have a magnetic field that in part deflects the bombardment,
solar wind, yeah.
the bombardment of Earth from the sun.
Yeah.
Are you involved in that? Or and more than that, do humans face a risk? Is that magnetic field changing, or
it's gonna flip?
I've heard that it might. I've heard that
Sure.
it's gonna flip. Are electronics gonna stop working? I mean, I've heard that at some point in the 1800s, there was an electromagnetic storm on Earth, and that you could even send telegraphs without having to connect it to the power.
Correct.
Is that how? Does your research have sort of direct impacts on how we see our future with electronics or our future on Earth?
Yeah, my research is to understand the space environment, that what would happen during such a time, for instance. So I like to look at the sun, and the sun is not only emitting photons, the light that we have outside, but it's also emitting this electric and magnetic gas that flies off the sun at supersonic speeds, and we call it the solar wind. And this solar wind streams out through the solar system, fills the whole solar system with this very low density but very fast electromagnetic gas. And that Earth has a magnetic field, and that magnetic field creates a bubble around our planet, and that bubble keeps the magnetic field, it keeps the solar wind and its magnetic field and charged particles away from Earth. And that's really good because it's not stripping away our atmosphere quite so much. It is, however, focusing some of that energy into certain spots in our atmosphere, which can cause lots of atmospheric loss at certain times and places.
And speaking of the reversal of the Earth magnetic field, I mean that blows my mind to think that for thousands of years we've probably been able to point a compass, and it's always pointed north. How would the flip in the Earth's what would that look like? What would that involve?
And should people hype it up and be as worried as it seems like people may be?
It's super cool, and it is sort of happening right now. No, we shouldn't be worried. Because it's not actually going to affect your everyday life, except we could probably see aurora from Ann Arbor a lot more often, which would be fun.
That'd be cool.
That would be cool. Northern lights are fantastic to see. It is happening. So right now it has been sort of the geomagnetic South Pole has been up in northern Canada for many years. And at the moment it's geologically sprinting away from Canada towards Russia. It's the pole has actually left Canada. It's over the Arctic Ocean, and it's moving across. In the southern hemisphere, the geomagnetic North Pole was in Antarctica, and it's slowly drifted over the last 400 years. It's in the Southern Ocean, and it's on its way moving as well. So both of these are moving. The northern hemisphere was fairly stable while the southern hemisphere was moving, and now the northern hemisphere is like doing its thing right now, moving. It's moving kilometers per year, so which is fast for geological things. So it's moving, and we have to keep updating that geomagnetic field that we use with our space environment simulations and understanding the observations. We have to keep thinking new about that. Is it actually going to flip? It could over the next thousands of years or something. So even if it flips in the next hundreds of years, okay, it's flipping. What would that mean for us? We still have a big, thick atmosphere above us, and so we really aren't in danger of having the energetic particles from deep space colliding with us down here on the ground. We would in only a little more danger than we are right now in terms of those energetic particles. Most of them are stopped in the atmosphere.
Okay. And then with the charged particles, I imagine some people may not know exactly how it works, so they don't see it like when they look up at the sky. But I think the best way to kind of relate to it is either if you've ever seen the aurora borealis up north, or seen like the tail of a comet, and it's always facing away from the sun. And so, what exactly is a charged particle, and what happens when it like funnels down at the North Pole to create the aurora? What happens when it strikes in a comet? Yeah.
So charged particle, a typical what we call neutral particle is a standard atom or molecule is the nucleus, which has protons, the positively charged particles, as well as a cloud of electrons, these electrically negative charged particles. And what can happen in space in this tenuous atmosphere, where some of the particles get to go really fast, or where some of the more energetic photons from the sun exist. When one of those smacks a neutral, it has enough energy to kick off one of those electrons and free it from the rest of the atom. And so now this is positively charged. It lost a negative electron, and the electron is negatively charged, and those two charges now fly around and have their own electric fields associated with them and are susceptible to Maxwell's equations, electric and magnetic forces, as well as normal gravity and other things. Mm-hmm.
So is that similar at all to, say, nuclear radiation? So if I'm thinking about, they tell me that, or it's common sense tells you should not go to Chernobyl right now, or especially like 20 years ago. Is this solar radiation, this space radiation at all? Is it a similar system? Is it equally dangerous for human beings to be exposed to it in large quantities, as sort of a man-made nuclear accident or something
exactly.
like that?
Yeah, so the two big populations in outer space, well, I guess maybe I should say three. So one of them is the Earth's radiation belts. So around Earth is this big donut of energetic particles moving really fast, close to the speed of light even, some of them, and they do a dance in this particular charged particle motion orbit, and they form this big donut of radiation around our planet. When we were flying to Apollo, we specifically launched them so that they would miss the heart of the radiation belts and not have to fly through that zone, because it can be harmful to humans. And same there. Another one is from the sun. Solar energetic particles. When there's a big flare on the sun has a big magnetic field of its own, and it's violent and splashing these particles off into deep space every now and then. And at times there can be solar energetic particle events where a big burst of them comes off the sun, and a big swath of the solar system is doused in damaging radiation. And then the third one is galactic cosmic rays, which are kind of there all the time. We can't really stop them in deep space. They'll go right through your spaceship.
Yeah, I remember hearing something about astronauts on the International Space Station.
Yeah.
They'd be sleeping with their eyes closed, and every once in a while they'd see like a bright flash with their eyes closed because of the cosmic ray.
Galactic cosmic rays going right through their head.
Mm-hmm. So is that something we should be concerned about, sending people to space, or even having satellites orbiting Earth? Do they eventually, will they eventually fail?
Yes,
of those
exactly.
radiation?
Yeah, so satellites are constantly being bombarded by these various types of cosmic radiation, and are slowly decaying and have to be replaced, either engineered so robustly that they can survive extra long and through their planned life mission, but even then at some point things are going to start breaking, and they have to be replaced. And so humans right now, we have limits on how long they can be in outer space.
I'm thinking back to sailors when we were discovering Antarctica, and they sailed off, and they were thinking, and months in advance, in order to avoid the harsh Antarctic winter and avoid getting trapped in the ice. If humans became more of a, if we had more and more people and more machines in outer space, would we need to develop space weather predictions? Totally. Is that a thing? Can we predict how the sun is going to bombard us? I think it'd be really cool if you had an app on your phone that said, today this place out in outer space is, I don't know, they could invent a new icon for sunny. Or
predict the aurora like a month in advance or something.
Is there interest in that? Are we doing that?
Go into your app store and type space weather, and there are several that you can already choose from to tell you when you're going to have the aurora over it. My favorite is Aurorasaurus, just because it's so cool. But it's one that scrapes Twitter for seeing when people are tweeting about the aurora, about the northern lights, and then tries to create a real-time map of where the aurora is, so that you know, oh yeah, it's being seen here. It's suddenly being seen over Michigan. People are tweeting about it. I better go out too. And so anyway, there are several other good apps out there right now that are telling you about this. Space weather is definitely a thing. I am actively involved in space weather, pushing our field of space physics into more space weather in order to be more applicable to human spaceflight exploration and to robotic spaceflight exploration. That you want to be able to protect these people and assets that are going into deep space, and you want to know when it's going to be bad weather out there. And yes, exactly. That's we've been working towards that as a field in general, and even me personally.
And then here at the university is the University of Michigan. Can a student here as an undergraduate how can they involve themselves with space weather, space sciences, and is there a major offered in the department, and how can they get themselves involved with research?
Yeah, definitely. Yeah, so my particular department has a major, space science and engineering, and in there you can choose between a space engineering focus that will lead you more towards the aerospace industry. I think it's called space instrumentation is the degree program there, but also we have a space science, I forget the exact name of it, maybe it's space weather, even that we call it, which is more gearing you to be one that knows the space environment and can help satellite operators understand what the hazards are that they're facing and help them make better real-time applications. Either of those can train you to go on into master's or PhD programs as well. We also offer a minor in I think the minor is for our entire department, climate and space sciences and engineering. But within that, you can specialize on the space side of things and take a series of courses, only a few, so it fits well with getting a different major to gear yourself to be understanding of the space environment so that you could take that with you into your career.
Definitely.
And as someone who's seen so many students over the years sort of pass through your department, some of whom go on to, I'm sure, become professors and researchers themselves, but the odds seem better to me from high school to become an NFL player than to become a full-time researcher, professor. What other things do people do after they, say, for example, get an undergraduate degree in physics, astronomy, space sciences? What other things are they equipped to do?
Yeah, and I think this is something where I would encourage all students to think about, not just the material that they're learning about in their courses, but the skill sets that you're acquiring in those same courses or in the various activities that you do, the sports, the clubs, the Greek life, the jobs that you have, that you're also acquiring these skills of for people in the natural sciences, astronomy and space science or climate science. I think that you're being taught to be a data scientist as well, and that you really learn how to handle a big, take this big data set, pose a question that that requires some big data set, find that data set that might be out there, analyze that data set, and try and come up with an answer to the question that you posed. And so you know many different skills. You have the critical thinking of how to pose the question in the first place. You have the technical skills of finding those data sets and processing those data sets in different ways. And the math skills to know what equations might help you in addressing that question. And I think that you are well trained to take that general problem solving, critical thinking skill set into other fields. The other big thing that I think you learn in many of these is that you have to write a lot of project reports or give oral presentations in these classes. I know that my upper level classes, every single one, I require both of those because that's a big hidden secret of my job. I said that I started this off by saying I'm in meetings a lot. The other half of it is that I'm talking and writing a lot. And so a big part of my job is coming up with reports and writing papers, but also writing in many different things for the different committees and teams that I'm part of. So that's a big, that big myth of being in the lab and saying eureka. You then have to go out and sell that science to the rest of the community to convince them that what you did was right. And so again, that goes to that skill set that we learned. That can be applied to any job past undergrad. If you are trained as a STEM undergrad, you have a great skill set that can move on to be applied in a wide array of jobs. That I think.
So you're in a specialized, what seems like a specialized field, specialized major, but you're graduating with a degree that says I'm a wonderful problem solver and thinker and analytical thinker.
I mean, personally, when people say, "Why am I studying physics?" I think that I like physics. I think it's interesting. I think it's cool. But what I think the most interesting thing that I've come to realize through my now nearly 2 years of studying university physics is that it makes you a thinker. You're learning sort of not only the history of how we've solved problems through time, and you're really, I feel like I'm just the last card on a deck of people who have thought long and hard about problems, and so you're kind of gaining this sort of, you're following in a legacy of people who've problem solved. Mm-hmm. And throughout the time of problem solving, of course, we've always been confronted with, how ethical can we do things, because obviously we know that sometimes we have the power to do things, but we shouldn't do it.
Yes.
And a lot of people who are fantastic thinkers come up with terrible ideas for the future of humans. Are you confronted with ethical questions in your day-to-day job, and do you see other colleagues in your departments do it, or other scientists here at Michigan?
Yes, I think that every scientist is opposed with that every day as they're moving through. How do you ethics is how you behave, and I think that that's a big part of trying to maintain the scientific integrity is maintaining a good behavior for the community. And when even just a few people violate that, it can really spoil that's what makes the news then, and it can really spoil the understanding of society about what scientists do. So I feel that burden every day, I think, in some sense, that I don't want to let the rest of the community down and make a bad choice in my own behavior. So I try, and I think most people do understand this too, or hopefully everybody, and tries not to make bad choices along the way in terms of how you're conducting your research. You can approach it with, I have a hypothesis of how this is supposed to work, and I really want my experiment to confirm that hypothesis, and so you can go into it with perhaps a bias, and the scientific method says you have to be okay to be wrong. Mm-hmm. And you have to be okay to say, you know what, my hypothesis wasn't right. You know what, my experiment wasn't the right one to do that. You know what, my whole approach is just wrong. I'm thinking about this wrong. I need to put it aside. Mm-hmm. That's something that if you don't take it with that ethical, I must be on good behavior approach to it, mm-hmm. you can get caught up in trying to say, you know what, I'm going to make it right. Yeah, and so that's a danger. So that everybody has to confront.
But with I imagine a lot of the research that's published and other scientists read, a lot of it doesn't have to be correct. A lot of it is it's wrong, as in they don't find the conclusion they were looking for, but still other people can read it and kind of base their research with those foundations.
Oh yeah. Mm-hmm. Yeah.
And going back to sort of the burden that scientists feel, mm-hmm. One thing that I'm sure many people are, and even I ask myself that question very often, is it's sort of a twofold thing. Is first, when we developed nuclear technology, it was for war. Mm-hmm. And famously, many of the scientists on the Manhattan Project, instantly when they saw the first atomic bomb go off, many of them thought, oh no, what have we unleashed on the world? Right. And Oppenheimer famously said, I am become death, the destroyer of worlds. How do you think wars can spark science? That's obviously a very complicated question, but seemingly a lot of our technologies stem from war that we've sort of revamped to make a peaceful use of. So how do scientists sort of navigate that world? Because people are always looking, human nature tells us that we should always be looking for a darker side of things as well. But how do scientists stay sort of in the clear, and how do you try, or how do you see other scientists sort of try to keep the right track?
You have to pull yourself back from just being in it for trying to claim success, and you have to be in it more for I want to learn something new for all of us, not just make a name for myself. And so I think that when you come at it with that approach, the approach of being more more humanity focused rather than self focused, your behavior can shift into better modes rather than into those places where you can get yourself thinking, oh my gosh, what have I done?
Is that a part of your teaching when you have undergrads? Is it part of the legacy that you try to pass on to them?
Exactly, yeah. To try and talk about this process of what is good behavior in science. In fact, everyone that goes through, that does research in a group, and being at a research university, I highly encourage everybody who's in a STEM field at Michigan to take advantage of that and work with professors in some directed research type of project along the way. That we have them go through a training for responsible conduct in research. Yeah.
And if we could shift the conversation a bit more to sort of the privatization of space, colonization, sort of all of these exciting things that are
right here in front of us.
Exactly. And I mean, you're the director of the Space Institute, and so I mean that has many implications. But obviously, my understanding of it is that it's trying to bring together many fields of research and of science that have an interest in space. So from law to business to science. And then obviously there's the role of SpaceX. We're going to have these satellite constellations.
Yep.
Could you explain your role your role and the role of your role within and the role of the Space Institute briefly?
So my role in the Space Institute is to help get it started and successful. I'm the current director of this process, and our long-range plan is to have Michigan be an active player in the global space industry, both on government and private industry side. We want to be creating the engineers and scientists and workers for the government and private space industry, and we want those people, once they're there, to see, wow, Michigan's doing great things, and want to come back and offer projects and sponsorships to student groups and multidisciplinary design projects and senior projects with those students, so that we have a two-way conduit between our current students and our alumni. We'd like for those two to be working closely together. On the faculty side, we'd really like to be bringing together people that don't normally talk to each other because we're stovepiped in our own little departments, and but you know what, this material, let's say I'm a material science person, and I've been working on something that works really well, and in it's a radiation hardened material, and okay, that's great if you're putting it into a nuclear fusion device here on Earth, but that's actually really good in outer space too, but you've never thought about that as the application. You've gotten your money in this other direction for your funding. And now, so what I would like to do is introduce you to the astronomy professor that might want to use that in their next space mission proposal. Oh, great. So making those connections and holding workshops and other networking activities that get those professors talking to each other. And not just scientist to engineer, but also, like you said, business and law, medicine, pharmaceutical stability in outer space. When these galactic cosmic rays, are they going to slowly change your Motrin? Or is that going to what's the influence of that?
And so obviously the commercialization of space is there's been an interest in space commercialization for a long time, but now we're starting to really see it with, for example, SpaceX soon being the only American carrier capable of sending people to space. How do you think that's, and so obviously I think many people think, oh, this is strange that it's no longer governments that it's only governments having the capacity to send people to space. And obviously with business is different than government. And so, for example, there are things like the Starlink project, which is aiming to send constellations of thousands of satellites to space to increase connectivity on Earth. And that sounds great from the consumer connected point of view, from the business point of view. But then many astronomers don't like that idea, because having so many satellites around Earth could cloud readings, could obscure the night skies. How do you think that the Space Institute, and and you within it will have to deal with these problems of sort of balancing science and business interests.
Mm-hmm. First of all, I think that we're on the edge of a huge blossoming of space travel for humans, and not just SpaceX. SpaceX is probably going to be the first American company, but Boeing is very close behind them. And then there's Blue Origin,
Virgin Galactic,
Sierra Nevada, or I'm sorry, no, it's something else like that. Virgin Galactic. Yeah, there are a number of other companies. Boeing and SpaceX have actually been working very closely with NASA. NASA has given them billions of dollars actually in order to develop their new human spaceflight capabilities. Again, to get people back up to the space station and move on to the moon and Mars. They've been working with Boeing on the big space launch system, the next big launcher. But again, SpaceX has also been developing their Falcon Heavy, and they sent a Roadster off to Mars. It went out past the orbit of Mars.
And so you grew up in an era where the government was paving the way, and they were always leading in terms of what was going into space. And do you see that there's going to be a transition, or the transition has already happened, where private
right
companies?
Now, and so having several billionaires think space is cool, I'm going to invest a lot of money. We are developing those capabilities that space tourism is going to be a reality for many people in the very near future. I want to say Virgin Galactic with its suborbital flight process that it's going to do, it's only going to be a few $100,000 only. Okay, that's a huge number. That's expensive, but that actually brings the cost down from the tens of millions that people have paid for a seat on a flight up into space with the Russians so far. And so if we can get that price down, that's we're talking 2 orders of magnitude drop in the cost. That's huge. That's like in the advent of computers back 50 years ago. It was developed by big government, things that had lots of entities that had lots of money in order to invest into it, and eventually it became more and more privatized and cheaper and cheaper and cheaper and more mass produced, and that's what I think is happening with space flight right now, and we're on the edge of a great revolution in sending people into outer space. I'm very excited about it, and I hope the Space Institute plays a key role in providing the future workforce and working with those companies and government agencies working with it to come back and help train that new workforce. So I'm really excited about the partnership that we can have with those companies that are exploring, working towards humans in space.
And obviously in any blossoming human endeavor, we've always found it necessary to sort of have order and create some law and guidelines to sort of have it go in the right way and not in the wrong way.
Yeah.
And with competing interests in space, more and more, even national interests still being high, are you seeing that? Are there going to be laws that are, and even with the Space Force that Donald Trump created? Is that how do you see sort of safe? Is space going to become highly military? Are we going to keep fighting for it? How are we going to create laws, to govern commercial exploitation? I mean, Rockefeller and Standard Oil crashed the field, first huge monopoly with oil, and that was 100 years ago. Do you think we might be heading towards the same thing, where we're going to have to regulate how big companies can get? Even with space mining, there's so many legal problems. How should people approach these kinds of problems because they're such novel fields?
Yeah, we definitely need to be approaching them. I think we are working on space law, space policy, and it has to be an international endeavor, because you're in space. You're not just over one country anymore. You're in low Earth orbit, orbiting above every country, and going off to the moon. Who gets what on the moon? I think there have to be international bodies that are discussing this and coming up with the processes for that. I'm not in that field, but we have to be addressing it, and you hit the right questions in the set that you just said.
Because I'm picturing if the USA creates a base on the moon and it happens to be sitting on something that's of value, other countries will want that thing.
Yeah.
So I'm sure there would be a huge mess of creating an international arbitration court for space resources.
Yeah.
That would be.
Yeah. And you know what?
Crazy.
People trained in astronomy and space science can take an active part in that. It doesn't have to just be lawyers or public policy experts. I think that people who are subject experts will play a key role in being a part of that. And so again, going back to that, what's the usefulness of a science degree if you aren't going to go on in that particular field? Well, you can go on in related fields of law and policy and business that are related to that science background that you have, plus using your problem-solving skills and data science, analytics, know-how.
And I was going to bring up aliens, actually.
Sure.
What would happen if, the concept that aliens could just be reaching out to us seems very far-fetched, but I saw an interview with Michio Kaku, who was saying that if you just look at the numbers and they make sense, there's no reason why we shouldn't be contacted by aliens, and it could happen. So, do you think if we were contacted, I know this is more in the science fiction realm, but how would we talk to them? Would they have peaceful interests? Would would we have space business to conduct with them?
And is it worth the billions of dollars that we've funded into like programs like SETI to kind of communicate or listen to the universe?
I think this gets into your question, the big trade-off of what's the right amount of money to be investing one direction or the other. I think it's good to listen. I don't think we need to have a lot of money devoted towards such an endeavor, but yes, we should be prepared. I guess there always is the chance that we are not alone, and that there is some alien life that's already populating our galaxy and coming close to our solar system and perhaps in contact with us soon. How would they how would they interact with us? Something that we've developed already is radio, and so I think that there's looking at modulating an electromagnetic signal, and that's what SETI is all about, is looking at radio frequency, what we've received from outer space, with big radio antennas, and trying to look for patterns in there. And is there something beyond just noise that's coming in from that part of space? And if you see some signal, oh, great, okay, I think that there's something coming from over there. And at the moment, whenever we see something like that, it's a natural signal. It's coming from some natural phenomenon. Okay, explained it and went through a scientific process to try and understand it. And if at some point we can't explain it with natural processes, and we think, this could be some extraterrestrial intelligence that's causing this, I would be surprised, but I wouldn't be, that wouldn't be totally taken aback.
I was gonna say, with over 4,000 exoplanets discovered and billions of stars just in our own galaxy, it seems like it's quite likely that the universe is teeming with life. It's just that, as I see it, with the cosmic speed limit, the speed of light, just in terms of civilization on the other side of the galaxy, and they communicate with us, they send something to Earth. By the time we receive it, they just send it in just that perfect time slot when we've developed that technology. Yeah,
right. Yeah, so there's a whole thing called the Drake equation. This guy named Frank Drake came up with this many terms that all multiply together to say, is there a chance that we will have some extraterrestrial intelligence communicate to us with radio right now? And it's you can go through those numbers, and you can get, because so many of them are
very unknown.
Unknown. It's you can get an answer that is a very small chance to much greater than one. In terms of how many civilizations are out there trying to contact us, and so I don't know the answer.
All of this comes from obviously deep in the realms of science fiction, but famously, science fiction authors have come up with ideas and concepts that technology was later able to create. Tintin walked on the moon 40 years before the real rockets were invented.
Yeah.
Has science fiction ever played a part in your actual research or in your research or in your interests in space? Because I think that Tintin, Jules Verne's, even Star Trek, they're crazy concepts, but sometimes when you think about it, it could make sense.
Yeah.
Have you ever had a moment in your professional career where you think, whoa, this is strangely reminiscent to something I read in a book?
I guess my hesitancy says my answer is no on that. I haven't come that close to science fiction in my work to be able to say this is approaching that level. Although I guess the closest is maybe the Fantastic Four, because they were created by cosmic radiation, and they morph themselves. And so the closest is, that the more I understand the hazards of space radiation, that they really can cause serious problems for humans. Okay, usually the human is that you get sick and eventual death, but so understanding that progression, that okay, what's the weird quirk that could cause you to develop super stretchy skin instead of death. No, I guess but that there is cosmic radiation out there, and that is a real problem. So I like to see in science fiction the nugget of reality that led to the story, and I find it an amazing testament to human imagination that we can go from one small nugget of reality. The sun emits neutrons, for instance. There's neutrons coming off the sun all the time. That they're going really fast, or neutrinos coming off the sun. They're moving really fast, and that they go through our planet and onward, and we can barely detect these things with big caves of water underground. That led to the movie 2012. Anyone see the movie 2012?
The apocalypse movie?
Yeah, it's an
Did it really?
movie. Yeah, because that was the premise. The small premise is that neutrinos were coming off the sun. They took it to some fantastically wild case of the neutrinos are now interacting instead of just being, very passive and boiling the inside of the planet, and therefore continents move. Total stretch of the imagination. I love to watch science fiction because I see the nugget. I'm like, okay, good. There has to be some nugget. And then they go wildly fantastic. And so no, usually there isn't much connection.
Obviously, I think one of the cool things that makes us human is that we dream of things. We can conjure up these wild thoughts. And Isaac Asimov apparently said that artists lack in their work when they can't find the facts and back it up with reality. And similarly, scientists sort of lose out when they can't make leap of faiths, they can't think artistically. How to be creative, it's a very broad question, but we're now constantly distracted by YouTube and things like that. How do you think humans can make sure that we stay creative, that we keep on thinking these wild things, and because hopefully that'll lead us to actual discoveries one day and help us, I think, have a better life?
Yeah. Great concept that people have been talking about recently called deep work. And I guess it's the whole concept of turn off your distractions and focus on something for at least a few hours. That you need that extended length of time to be distraction free and focused on a particular topic. And that's something that I try and do in my work life too, is find times where I can be distraction free for an extended length of time. That's how I get my own research done right now, is to intentionally not have meetings, intentionally not answer email, intentionally stay away from the internet for a while, and actually focus on writing that code to do some analysis, writing that paper to explain that analysis, writing that report that conveys the information that we need to. So finding some block of time to be creative. And I think that goes not only for conveying what you're doing and doing what you're doing, but even at the very beginning of trying to think about how to approach it. The whole scientific method starts with seeing something strange and thinking up a hypothesis of what might be the answer to it, and then an experiment for how to test that hypothesis. And those two are very creative processes. If you don't have a good active mind to come up with that hypothesis and that experiment to test that hypothesis, your science isn't going to do very well. So you need to have the creative process in it. And I think a key way to do that is to turn off distractions for a while. Even just a few hours is enough to focus on that.
And Joe had mentioned earlier about like the dark ages and there not being really progress
Yeah.
in science. And do you see there being a risk, and even though we have this technology where we have all the information we want at our fingertips, do you see some risk in the future where people are becoming too comfortable in their lives, people are not thinking on their feet and using that creativity, or do you think it's all for the better, having all that information?
I guess it depends on how you take it. So in general, technology is not evil. Technology is not good. It can be used in either direction. And so same thing with that initial creation of atomic energy and nuclear energy, and so on. That it was not used for a good purpose immediately, but it was but now we're trying to use it for a more to satisfy the energy needs of our world. Same thing with technology around us. It's great that I'm able to look up answers to questions. I see something strange, I can very quickly say, has anyone else seen this strange thing before? And find out if I even need to pose a hypothesis. No, I don't. Look, 3 people already have papers on this. I got it. Okay, let's move on. I can focus my energy better because of technology, and I'm more efficient at creating that experiment and running the experiment because of technology. It can be a distraction though. And so that whole thing of creating free zones where you can focus your work focus your efforts on one thing is also needed. So yes and no to technology.
I think we had one last question
Sure.
for you. If there was one moment of your career or of your life that you could revisit because it was so good, what would it be?
So good, or that you see something you could have changed, maybe?
Oh my. I like my life. I love my job. What would I what would I relive? I love back when I was just starting out, writing those first numerical models, taking that set of equations and coming up with those first plots and answer. That was a time of discovery for me. That I can actually do this.
That was your eureka moment.
Yeah. In some sense, that was my first eureka moment of saying, I got something. Look at that. I went from this sheet of paper with all these symbols on it to this sheet of paper with this cool graphic on it, and I understand what this is trying to tell me. That was a fun time. Something I would change if I had to go back, I might have taken AP English.
Just because as a scientist you didn't realize how much writing there is.
Right. Yes, exactly. I do a lot of writing. It's that whole thing of going back to the myth of the scientist being the quiet introverted nerd. It's so much better to be a well-spoken, well-written person that can sell your work and be part of a scientific community. I'm part of a community that I have to go to meetings and talk to these other people, network with them, and try and get them to appreciate what I've done and me to understand what they've done, so that I'm building off of what's known rather than reinventing what they've already learned. So we have to be part of this big community, and we have to be engaged in public speaking, in a lot of scientific writing, and a lot of things that we didn't guess were part of your life when you were choosing physics, astronomy, space, climate, whatever the STEM field is. That you didn't think that was part of it. Yeah, it's actually a huge part of your life.
Yeah, I mean, the more I've progressed through my at least university career in physics, I've realized that people have always told me that scientists can't write, but I've never seen that being evidently true, because every time that I've read something from a scientist, it's always very logical, it flows through, it works. Whereas oftentimes I find myself reading other things, I'm like, this is not the clear and concise style I'm used to. This is very long and elaborate and sophisticated.
Mm-hmm.
Cool.
Awesome. Well, thank you for joining us today.
Thank you.
This is Professor Liemohn, the professor the Department of Space and Climate up on North Campus. My name is Michael.
And I'm Joe.
And thank you for joining us for our first episode of Everything Astronomy.
Thank you for having me.
Thank you.